We are here today to talk about the future of precision nitrogen management. I promise you it might be quite exciting. So before we start, I would just like to say a huge thank you to Hutchinsons for believing in us, to Jenny and the team for being such phenomenal and supportive partners. I would also like to thank all of the farmers that participated with trials with us, all 14 of you from Hutchinsons, Andrew and Richard, and in particular, Tom Dewars and Nick Wilson. You gave us so much time and advice. You helped us understand how we could help your farm in particular and all farms, and we're really, truly grateful for that time and also for the amount of hours you spent sampling in the fields, countless hours. So thank you so much. If we could please just a quick round of applause for those farmers. We are truly grateful. So, quick agenda today, we're going to talk about the science of optimum fertilization, the research that exists. Any good technology needs to apply the research. We're going to look at existing legacy products and how they can struggle to apply the research. And then we're going to look at the transformative power of hyperspectral satellites and how they can help. So quickly then, just to talk about our name, thank you for the introduction. We have taken it from the Harvest Protector constellation. You can see the shepherd there, looking over their crops. And really our purpose in Messium is to add value. If we can't add value, we will stop doing what we're doing. We're never going to be perfect. Agriculture is very complicated. We're constantly learning, and that's what we want to do. We want to move fast, we want to learn and improve. So if we don't get something right, we always view that as an opportunity to be better next time. We are backed by the UK Space Agency, the European Space Agency, and UK Innovate, as well as private investors. So my name is George. I'm one of the founders. I have previously founded and sold a couple of startups, and I met Vishal, my co-founder, at a climate technology networking event. Vishal and I both care about protecting the planet and doing something positive for the planet. Vishal has a background with his satellite business called Complexity. He was forecasting forest fires and won numerous awards from NASA and the European Space Agency. He's a phenomenal technologist. In the room, we have other members of the Messium team. There are 7 of us today. Please come and chat to us afterwards. And I would also say the extension of our team are the researchers that we've worked with this year. In particular, Pete Berry from ADAS. I'm sure many of you in the room are familiar with him. He's one of the world's leading wheat physiology researchers. He's given us potentially even 100 hours of back and forth over email and times on calls, and he's really helped us advance the science. There are many other researchers as well that we work with globally. So looking at the science then, we're very lucky that there's been a rich history of science into optimum fertilization. In the 1980s, a French researcher called Gilles Lemaire started studying and doing lots of different nitrogen rate trials and amounts, and he was interested in the amount of nitrogen at which the biomass of the crop did not increase anymore. And that is what has led to the nitrogen dilution curve that we see back here. So along the x-axis, you see biomass, 1, 2, 3, 4, 5, 6 tons. For any biomass, there is an optimum concentration of nitrogen in the crop, which is seen on the y-axis. So the red line is optimum. That's optimally fertilized. If you're above the red line, the crop is absorbing additional nitrogen, but that is not contributing to additional biomass growth and therefore yield and profit. It's luxury and it's wasted nitrogen. If you're below the red line, your crop growth is stunted, the crop is deficient, and therefore your yield and profit is stunted. We have collected all of the research papers from across the globe. There have been many studies over many decades, so we've collected 3,000 research points from there, and we've added about 4,000 of our own research points. So this is the starting point, understanding the nitrogen status of your crop. The next thing we need to understand is your particular farm. So your soil type, the previous crop, the wheat variety you're growing, the drill spacing. And we put all of this information into the crop growth models. There are 2 leading models that we use. And the big innovation that we're driving is weekly updates. So a weekly nitrogen insight and then weekly updates as to what's happening on your farm. So we also model days of sunshine, days of rainfall, soil moisture, soil organic mineralization. So we're trying to build a complete picture, and we're the first company that's trying to do this on a weekly basis. That's our big innovation, and this is why all of the world leading researchers that are building these crop growth models that are phenomenally detailed are excited to work with us. So let's look at the legacy solutions and potentially why they might fall down. Lab tests are brilliant. They're extremely accurate. They can tell you the nitrogen concentration and the biomass of a crop. But it's very time-consuming to take a lab test. They're very expensive. There's a lot of variation within a field, let alone between fields. Handheld sensors are similar. They're just less accurate, and frankly, they just don't scale. Satellites, then, that's the obvious answer. Satellite can image your entire farm. It can be very cheap. But the problem with the previous generation of satellites is that they can only do biomass. They can understand different levels of green density in the crop. They can tell you how far along the x-axis of the nitrogen dilution curve you are, but they can't tell you if you're above or below the red line. They simply can't do nitrogen. Hyperspectral drones do have potential. We can see here in the picture, that's Tristan, our drone operator. We took some drone images. We took about 30 this year to compare them to our satellite images. That drone and camera setup alone cost £400,000. Very, very expensive. Drones have limited battery life. There's all sorts of calibration issues with the sun and the clouds moving. The data collected is immense. We were imaging every 10 centimeters. It was so much data, we couldn't email that across the internet. He had to post us a hard drive. So drones, they're sort of an inferior equivalent of satellites. So then tractor sensors. Tractor sensors can detect some of the nitrogen wavelengths. They detect 5 wavelengths, whereas hyperspectral cameras can detect up to 450 wavelengths. But the big problem with tractor sensors is they can't do timing very well. A tractor can go onto a field, but your crop has potentially already been deficient by 1 or 2 weeks, so you're already losing there. Or the inverse, the tractor will be spreading when your crop already has lots of luxury nitrogen. If the crop is already saturated, then it struggles to absorb additional nitrogen. So let's look at hyperspectral technology. Visible image that we see is 3 wavelengths. It's red, green, and blue. Hyperspectral goes into the infrared and invisible spectrum. But just like we can see different colors, every chemical on Earth will absorb and reflect a different wavelength. The squiggle, the wavelength for every chemical is different. It has basically a different invisible color. We call that the spectral signature. So we can very clearly see the nitrogen in the crop. We can see the amount and the intensity of the nitrogen. So just to round this home, hyperspectral satellites are the first ones that can detect nitrogen in the crop. It's the equivalent of doing a lab test for every 5 meters square of your farm every week. There are many other really interesting use cases for hyperspectral. The research has proven that it can detect signs of disease, septoria, and yellow rust 2 to 5 days before signs are visible to the naked eye. Mining companies have started to use hyperspectral to look for rare elements in the desert, gold, copper, lithium, and gas companies are using hyperspectral to spot gas leaks on their pipelines. It's really promising technology. A quick history. So NASA launched the first hyperspectral satellite 20 years ago. It was very big. It cost many billions of dollars. The European Space Agency launched a satellite about 10 years ago. And this year, the first commercial small satellites were launched. So thanks to SpaceX and Elon Musk, we now have far more powerful commercial satellites. Next year, we will be working with 7 companies, and they will have a total of 15 satellites. That removes all of the problems that you might have experienced with cloud cover. So if you've used an NDVI satellite map before, they're probably using maximum 2 to 4 satellites. That means they fly overhead around every 10 days. So it's very easy to get cloudy, 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 cloudy image. With 15 hyperspectral satellites, there is a satellite above your head every single day. It means that in a 2-week period, it's very likely there will be 1 cloud-free day. We did some analysis of the UK from March to June, and there's a 96% chance of capturing a successful image. So Messium, we are the first complete product. We do accurate nitrogen. It's cheap, it's frequent. We do crop growth modeling, we do biomass, and importantly, we do weather. Of course, weather is very difficult, Tom. I know that. But we are, through our European Space Agency connections, working with the ECMWF. It's the world-leading center and research. It's this supercomputer that cost 100 million, and they give quite good directional forecasts. So the 7 and 14-day forecasts are great, and the 56-day forecast can basically tell you directionally, is the next month going to be wetter and colder than average, or is it going to be drier and warmer? In December, they predicted that this summer was going to be very cold and wet, and it turned out to be. We could do a whole separate presentation on weather. We have a lot of experience in water-limited yields through our work in Australia, so hopefully we can follow up on that one. So let's look at 2024 trial results. Firstly, we sampled 47 farms from across Europe. We collected over 1,000 samples, and we sent these off to laboratories. They told us with high accuracy both the nitrogen concentration and the biomass. We could then put these data points into the nitrogen dilution curve. We could see and calculate how far above or below the red line these samples were. The results are as follows. 51% of fields were over-fertilized by an average rate of 40%. 39% of fields were under-fertilized by an average of 28%. The error is gigantic, and it's completely understandable. There is no good way to understand the nitrogen status of your crop on a weekly basis. So in the UK, we ran trials with 14 farmers, and we were able to show benefit to 10 of those farmers. We were using a basic crop growth model and recommendation engine that we built with Pete Berry at ADAS. But obviously, the error is so huge that even a basic model was able to show benefit. We had one farmer that had lots of luxury nitrogen in their crop by the third split. We said, please don't apply any nitrogen in our strip. And the yield was just as good at the end of the season as the rest of the farm that received a lot more. The farmers we work with are demonstration farmers. You're quite rightly trying to apply less nitrogen. And with 6 of you, we helped apply 20 to 30 kilos more per hectare. Here is a map of one of our farmers. The Messium strip is at the bottom in blue. Of course, there is natural variation across the field, but if you can see in the top right-hand corner, the average, it's very small writing, was 5.2 tons per hectare, and then at the bottom of the Messium strip, it was 7.7 tons. So the rest of the field received 130 kilograms. We actually applied 160, and it's a pretty phenomenal result. We had 3 farmers in the UK where nitrogen was not the rate limiting factor, and we've seen this a lot in Australia as well. So we knew that a lot of nitrogen had been applied, but the crop wasn't responding. This indicates another issue. It could be P, K, manganese, calcium. There are many other probable causes. We can signpost this early so you can do a land crop soil test, and hopefully you can take corrective action to make the nitrogen more effective. So in Australia, we did lots of trials and we gave recommendations to 27 farmers. We used a far more advanced recommendation engine, and we were far better at bringing the field back in line with the optimum red curve. Globally, we have collected over 13,000 samples from many, many trial sites. Each sample is a 50-centimeter row of crop. We send that off to the laboratory. They tell us the nitrogen concentration and the biomass. Each sample has a unique GPS pin, and then we match that data to the satellite image. The more times we do that matching, the more accurate and the more powerful our AI model becomes. In the future, we want to give you these recommendations with no need for sampling, and we want to replace the need for an expensive lab test. Our model is already very, very accurate, and it's ready to go next year. So let's look at some UK data. Timing, we have seen, is extremely important. Of course, if you're fertilizing and your crop has been deficient for 1 or 2 weeks, then there'll be a big yield loss. We've got another example, and we've seen this many, many times, where fertilization is occurring when the crop already has lots of luxury nitrogen. It's saturated, so if you're applying nitrogen at that point, it's much harder to absorb the nitrogen. We've got a really interesting case here from East Anglia. So we did 8 different nitrogen rates from 100 kilograms all the way up to 250. And let's zoom in on some of the results. So the farm standard strip was 200. There were actually 2 of those. There was a control. And if you can see in the green, it yielded 11 tons per hectare. There was a higher strip that had 225 kilos, and that yielded 11.3 tons per hectare. When we were taking samples of the Messium strip, we saw that our strip had luxury nitrogen. So we asked Tom to go and apply the nitrogen 12 days later than the rest of the field. And thank you, Tom, you're an absolute legend. You went and applied just that one small strip later. Because then that strip had reduced the luxury nitrogen that was in it, it was far more able to uptake the nitrogen when it was applied at the time. So more nitrogen got into the crop, and that yielded another 0.5 ton per hectare more. We only applied 2 kilograms more, but much more got into the crop, and it was a far better result. In fact, we yielded ever so slightly more than the 250 kilogram strip. So timing is crucial, and of course, we can do timing with the curve. The nitrogen dilution curve tells us when your field is likely to be deficient. The crop growth modeling tells us how much to apply. So moving on to 2025, we would love as many of you as possible to pilot and join Messium next year. So we will provide nitrogen heat maps of the entire farm. We will pinpoint the fields with the greatest over-fertilization and the areas with the greatest under-fertilization. We also want to take lots of lab samples. The satellite model is very accurate and very powerful, but we want to make absolutely sure we're giving you the best data possible. So we will send an independent sampling technician, and they will collect 30 to 50 samples 3 or 4 times in the season. We want to make doubly sure that the data is accurate. We'll give you timing and quantity recommendations, and at the end of the season, we will do a benefit assessment to understand the impact of your entire farm. Participation is straightforward. We ask that you vary nitrogen in 2 rates, in the most over-fertilized area and the most under-fertilized area. Start with a strip. If you want to do half a field, split field, that would be fantastic. We had one farmer the other day asking to do his whole farm. We ask that you are prepared to do this at different times and that you're prepared to collect the yield data as well. So we can't do this without you. The trial itself costs about £3,500. The independent labor, the lab costs, the images, it's all very expensive. So we ask that you make a small contribution towards that. £300 up to £600 if the trial is very expensive. In return, we will offer a £1,000 discount to use Messium in the future. And we also guarantee that the Messium strip will show a 7% net improvement compared to the strip next door. If we do not demonstrate that, we will refund the money before you even ask. We've got the data. If you're unhappy with any element of the trial, we will refund that cash. So now comes the point where I want to double down and I want to ask for your participation. If there's one thing you try next year, we ask that it is Messium. The sooner you can validate Messium, the sooner you can accelerate your benefits at scale. But there's an even more important reason to try Messium next year. We need to show your support to our investors. It's incredibly difficult to raise investment in the ag tech space. We've been introduced to hundreds of investors, and we've had the same response, or rather, 80% of these hundreds of investors have not even taken a phone call with us. When we do take a phone call, this is the response. We have since discussed and decided not to proceed with the investment. This is because we are concerned about the challenge of selling to farmers and through corporate partners. Notice, they don't question the science or the technology. I've spoken to over 60 investors, and we've had this exact same response from virtually all of the investors. It breaks my heart. They're basically saying that it's a massive struggle to sell technology, even when it's proven, and that doesn't make sense to me. You're all here today because you care about improving your farms. You're all here today because you care about protecting the planet. And so I've got 2 asks. The first ask is that you sign up to messium.co.uk and follow our newsletter. If you all don't mind, if you could take out your phones now and go to our website and put in your email address, we would love it if you could follow our progress. The second ask is tonight we will send a survey. If you could take part in that survey, it's 4 questions where you can indicate willingness to take part in the trial. We would love it for as many of you as possible to be part of this trial and to work with us next year. Please help us show our investors that you believe in the science. Please help us show our investors that you are keen for positive change. Thank you.
George, we've got quite a lot of questions coming in from the floor. So we're slightly over time, but I think I'll just ask one. Can third parties use hyperspectral satellite data from my farm without permission?
Well, you would need to do the ground truth, but yes, potentially you could understand what was happening. Yeah.
So how safe is the data? So if a farmer signs up with you and they get the information they need to do all the things that you say you can do, how safe is their data?
The data is always protected, so we would never ever use or distribute another farmer's data or give it to anybody other than the farmer. It is completely your data, and we will respect that 100%.
And there's one other question. Have Messium done any work with sulfur and nitrogen efficiency?
So next year, as part of our UK Innovate grant, we have budget to look at some of the other nutrients, so sulfur, P, K, and various others. We are collecting that with the UK AgTech Centre and Hutchinsons.
Thank you very much indeed. Very, very interesting. Thank you.